we're asked for A intersect B complement. So that means we need to find out the set that happens when you take the set A and find out where it crosses with B complement. That's kind of a mouthful, so it's easiest probably to look at a Venn diagram here. Could have drawn it a little bigger, that probably would have helped me. So when you draw the Venn diagram, we could let this be the A and this be the B, though it doesn't really matter, you could do it the other way around. Let's see where they intersect. We have a 5 in both of them, so I'm going to cross that out. We have an 11 in both of them, so I'm drawing that we're in the intersection of the two circles. And I think that's it. We've got a 99 over here and a 24. We've got a 3, an 8, and a 9 over in this set. So what's A intersect B complement? So one thing I try to have students do to help with Venn diagrams is, look, let's make dots for where A is. This is circle A, the blue dots that I'm putting here. And then for B complement, I'm going to put stars. So B is this the circle on the right side. So here's a star, because that's B complement. That's everything that's not B. B complement means basically not the set B. This is B complement out here. This is still B complement over here. Where do they intersect? Where do the blue dots and the orange stars cross? They cross at the set of 3, 8, and 9. Let's see what else we can get in this topic. Set operations, I'm going to skip this one because that's similar. Draw the Venn diagram, and A intersect B complement. That means, this is A intersect B, right? When you draw your Venn diagram. So A intersect B complement means everything outside of that circle. Find the difference in Cartesian product of two sets. Okay. So this question is asking for the Cartesian product. So the Cartesian product of F and E. Basically what that means is that you're supposed to pair up all the values in F with all the values in E. And now the order is specific here. They said F and the Cartesian product of F with E. So that means we have to take the numbers in F, the 44, the 8, and the 2, and those have to pair first. So when we find this Cartesian product, we're putting in parentheses 44 comma 1 because I'm closing the parentheses because that's the element of F combining with an element of E. Then we have to do that for all the other combinations. So you could do 44 again from F with the second element in E. And then you could do the 44 and combine it with the third element in E. 44, 13. I think you get the idea, right? Because then we go to 8, and that needs to pair up with the 1. The 8 needs to pair up with the 2. So let's see which one's going to be our correct answer. These are wrong because this would be the Cartesian product of E and F. The order matters. Okay. And then looking at these options, 44, 1, 44, 2, 44, 13, that looks good. 8, 1, 8, 2, 8, 13, 2, 1. This one, the order gets switched. It should say 2, 2 here. Okay. Now, if it asks for the difference, what is C subtracted by D? That means take the elements of C and just take out any elements that match with D. Like 676. There's a 676 over here, so we're going to take that out, okay? So C subtract D is going to be right now nothing because 676 subtracted by, there's a 676 in set D, so that gets erased. Now 80 gets subtracted by 80, and then 4 doesn't have anything to subtract with it. So there's actually one element left when we perform the subtraction. Notice the order didn't matter there, right? When you subtract two sets, 676 just needs to be an element in the other set in order to disappear. It doesn't matter if it's in the same spot. Venn diagrams. So this is asking for A complement union B complement. So I can get that over so we can draw on it. Because I'm fancy like that. Alright, that's good. Here. We're asked for A complement union B complement. So I think I actually just did this in this video, right? Let's start off with A complement. I'm going to draw red dots for A complement. So that means I'm not drawing any red dots anywhere in the blue circle. Here's a red dot, here's a red dot, here's a red dot, here's a red dot, and technically red dots on the outside too, if there were any events on the outside. So these are this is A complement. And then let's do B complement. So B complement I'll do in stars. So that means everything except B. So this is B complement because this is outside the circle of B. This is B complement. This is B complement. These are the two locations of A complement and B complement. So A complement union B complement means we include all the numbers that fit this criteria that either are in the stars or the red dots. Okay, and it's okay that there's no stars here. If this was an intersection like that first problem we saw, then it has to be only where they cross. The intersection would be the empty set. They don't cross at all. Oh wait, sorry. They do on the outside, but there's no elements there. It's not the intersection though. This is union. So that means include all the blue stars, include all the B complement values, and include all the red dots, include the 11s over here. So starting with the blue stars, I've got a 3, a 5, a 4, and a 2 in that section. And then with the red dots, I've got an 11, a 10, an 8, and a 9. I think that's everything unless I missed something there. Okay. Okay, determine the cardinal number of a union of two finite sets. So remember, the cardinal number means how many elements do you have in the set. So it's basically combining what we did earlier. We want to find out what A union B is, and then we can find its cardinality. So A union B means all the elements, all the unique elements of A and B. We don't do any duplicates. So I'm looking at set B. That's the smallest number, -1, then 2, then 3 comes next. Do we have a 4 in either one? There's no 4. How about a 5? There's a 5 in B, so that's in our A union B. Just remember, we don't duplicate, right? No 6s. There's a 7. There's no 8s. We'll deal with that H in just a second. There's no 8s. There's no 9s. There's no 10s. There's an 11. There's no 12s. There's a 13 in set B. There's a 15 in set A. There's a 17 in set B. Oh, and then the H you can just tag on anywhere, okay? It doesn't necessarily have to be in order, especially for this question. Okay, unless I missed everything. The cardinality, remember, is just the number of elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 elements in that union set. Okay, I hope that helps, but you can still message me if you need help. I'll be happy to help you if you're stuck on a question.